In the short form of the story, light, regardless of pulse structure, does three main things. First, interacts with the water in the body to create pressure gradients that stimulate capillary blood flow and enhances perfusion of blood into the tissue. Second, it interacts with hemoglobin to increase the amount of localized oxygenation of the tissue. And finally, it interacts with the mitochondria of cells to enhance the efficiency at which cells create and use chemical energy. Combined, this leads to a general effect of stimulating the body to function exactly as it does naturally, only faster and more efficiently. Digging in a little deeper, when light is absorbed in water, the energy gets converted into localized heat packets that lead to microscopic changes in pressure along the paths of blood vessels. These pressure gradients stimulate blood flow to flow into more far-reaching parts of the circulatory system, and equally as important, to be drawn more readily to the veins, carrying more waste products away from the site. In this simulation, you can see that even the simplest change to a steady flow can lead to all sorts of new avenues for the blood. Within the capillaries, there is also an increased perfusion of blood. You can see from this microscopic look into tissue, even when blood vessels are not visible, light can push red blood cells and nutrients through the tissue to places it may have trouble reaching otherwise. The second type of interaction comes with hemoglobin, whose iron core attaches to oxygen. Iron absorbs very well, and when it does, the resultant heat changes the shape of the molecule enough to stimulate the release of oxygen. So when light hits oxygenated blood, the probability of oxygen is released increases. More oxygen to more cells is a very good start. The blood is very good at channeling oxygen molecules to the most useful part of the cell, the mitochondria. On its membrane lives a series of respiratory enzymes that initiate the process of ATP production. The final stage of this process involves a carrier molecule called cytochrome oxidase, whose main role is to carry fresh oxygen to ATP synthase, where ATP is created. At one end, it oxidizes, accepting the oxygen, and on the other end, it reduces, delivering the oxygen to ATP synthase. Every time it drops off an oxygen molecule, another molecule of ATP is formed, providing chemical energy to the cell. Then it has to go back for more. This molecule is special, one, because it contains copper and therefore absorbs light very well, and two, because when it does, regardless of which transient state it is in, it will tend to switch. So if it's reduced, it will oxidize, and if it's oxidized, it will reduce. So the more light incident on the cell, the more ATP can be produced and the more energy the cells have to heal themselves. This is laser therapy. Again, it brings more blood to an area, extracts more oxygen out of the blood locally, then stimulates the body to use that oxygen more efficiently to create the energy the body needs to carry out all the natural healing would have done, but faster.